Hello everyone, welcome in online series for Geotechnical Engineering. I am Professor Siddhi Borade from Vishwabharati Academy's College of Engineering, Ahilyanagar. In previous series, we are understanding about what is soil and what is geotechnical engineering. What is soil? Soil it is a complex material formed from weathering of rocks and rocky minerals. Then, in this series or in this lecture, we are understanding about the three-phase diagram in geotechnical engineering. What is three-phase diagram in geotechnical engineering? The three-phase diagram shows the properties of solid, liquid, and gas phase in system. They are also used in material characterization, such as what are the type of material used in construction. They are classified or they are shown in three-phase system. The three-phase system has the equilibrium study. For example, the soil composition analysis for construction project shows soil, water, and air properties to determine the stability. To find out the stability of the soil, we are use the three-phase system in geotechnical engineering, and this is the application of three-phase system in geotechnical engineering. But in three-phase system, there are some values as shown in figure, uh, the volume relation in three-phase system. In three-phase system, we are study in previous lecture what is the three-phase system and what are the components of three-phase system. In this three-phase system, the main component, the volume, total volume, we are calculating the total volume. But what is the total volume? It is called as the sum of all volume in the system. In three-phase diagram, we are shows the three part or we are combine a soil in a container and the container fill with soil. The soil contains solid, liquid and gaseous part, or we can say the uh, total volume is contained with air, water, and gaseous substances. And the total sum of this all substance, it is called as the total volume or the total volume that indicates the capital V. The volume of solid which we is in this container is calculated by the the space occupied by the solid particles. And next one is the volume of water is calculated by the space occupied by the water. Then next is the volume of air. The volume of air is calculated by the space occupied by the air. It means the total volume is calculated the sum of all solid, liquid and water particles present in the container. It is called as the total volume of in this three-phase system. But as we are seen, the three material or three particles are present in container, but the some space is available in container, and the space we are also called as voids. It is indicate in V and small v, capital V and small v. But the total volume of voids are calculated with the sum of volume of air plus volume of water. These are the main definitions or main parts or volume relationship are present in this slide. That is the volume relationship in the three-phase system. Then next slide shows the mass relationship in three-phase system. The mass, that is first we are seeing the volume is present in three-phase system. The next slide is present the mass relationship in three-phase system. The mass relationship, that is the mass of all material, that is the sum of all masses in this system, it is called as the total mass of the system. Then next is a mass of solids. Mass of solids, the mass of solid, it is mean by the mass of solid particles present in system, it is indicates ms, it is the mass of solid. The next one is a mass of water. The mass of water is the mass, total mass of water present in soil, it is called as a mass of water. Then next one is the mass of air is negligible in calculation. As we are seen in previous slide, the total volume is calculated the sum of all volume in system, and mass is also calculated the sum of all masses in system. But in volume, the total volume and the voids are present in volume are also considered. In masses, there is negligible consideration of air. It means the presence of air is not calculated in mass of total mass in three-phase system. The next one is water content. In three-phase system, we are shown volume and masses calculation. Then the main or next definition, main geotechnical index, or we are also it is called as the main index properties. The first is the water content. Water content is the first in important index property in three-phase system. The water content, it means or it is called water content by the definition. The definition for the water content is the ratio of mass of water to the mass of soil. It is called as water content. And the formula for calculation of water content is W is equal to mW upon ms. It means the mass of water divided by mass of solid. Mass of water mW divided by ms, that is mass of solid into 100, and the result shown the water content. But why we are calculating the water content in geotechnical engineering? The first is the find out the soil strain, compressibility and permeability. For the finding out soil strain, compressibility and permeability, we are find out water content. Then next one is next main property or main index property is void ratio. Void ratio is the ratio of volume of voids to the volume of solid. It is called as the void ratio. The formula for calculation for the void ratio is E is equal to, E indicates void ratio. Then E is equal to VV upon Vs. It is called as void ratio. But why we are calculating void ratio? To find out the compressibility of soil, and the high ratio of high void ratio leads to higher compressibility and potential settlement. And The indicates wide ratio indicates the soil density and compaction level. These are the main or the important index properties. And for the finding out this index property, we are shown in previous slide the some formulas and the relationships, that is volume relationship and mass relationship. With the help of these indications, we are finding out the main index properties. The first one is water content. The next is wide ratio, that is small e. The next index property is porosity. Porosity, it is called porosity. Why it is called porosity? The definition for the porosity is the ratio of volume of void. That is, we are shown the ratio of volume of void to the total volume. What is VV? That is ratio of volume of void. That is volume of voids present in three-phase system divided by total. That is the total volume we are seeing. What is total volume? Total volume is the sum of all volume in the system. It is called as total volume. Then next one is total total volume is the next one is the formula for porosity is small n is equal to VV upon V into 100. It is called as the porosity. And the porosity, high porosity shows for better drainage and aeration. Porosity is indicate, the high porosity indicate the better drainage and aeration property. Then next is the degree of saturation. Degree of saturation. Next important index property is degree of saturation. The definition for degree of saturation is the ratio of volume of water to the volume of voids. It is called as the degree of saturation. And the formula calculation for degree of saturation is S is equal to VW upon VV into 100. It means it indicates how filled the voids in water. That is, the voids are present in the three-phase system are calculated in by the help of degree of saturation. The degree of saturation affect the strength and hydraulic conductivity. The degree of saturation is affects the soil strength. By the differentiation of degree of saturation, the strength of soil is also varies. This is the important index property. With the help of this index property, we are calculating some different problems in geotechnical engineering. Then next one is the unit weight and density. Unit weight and density. The unit weight, the bulk unit weight, it indicates in this figure we are shows some formulas for calculation of unit weight. That is, first one is bulk unit weight, then dry unit weight and saturated unit weight. The bulk unit weight is shown in formulas are shown in this picture. Then next is the interrelationship of index properties. some formulas are shown. First one is first formula, then second one is with the help of dry density or dry unit weight. Then next is with the help of these formulas, we are calculating index properties. For understanding this relationship is important for solving geotechnical problems. In geotechnical problems, we are um, used these formulas. Then next is the application of index properties and the three-phase system. The application of three-phase system, we are seeing three-phase system from previous lecture. What is three-phase system and made index properties and their application. But why we are studying about three-phase system? The application of three-phase system is categorize the soil on based on their properties. It means the differentiation of soil with the help of uh, index property we are used the three-phase system. Then next is ensuring proper soil density. And next one is for the settlement analysis, we are use the three-phase system of the soil. The understanding index properties is the important in geotechnical engineering. These diagrams are the significant for the soil characterization and engineering design. And this is the application, the main application and the main purpose of finding out this index properties in geotechnical engineering. So you are understanding about three-phase system, their application and some formulas for calculating geotechnical problems. These main important formulas for finding out the solution in geotechnical problems. These are some main index properties. So thank you for watching this video. Thank you so much.